Well, hello, ladies and gentlemen. This is our 2018 through 2019 school year, part 1, questions 1 through 22 of the test review. So let's see here. Let me make sure to get this thing centered. Zoom out a little. All right, what is the charge on an aluminum ion? Well, first off, aluminum lives right over here in group 3-tene or 3A. So aluminum's Lewis structure, they always seem to come down in this unit to Lewis structure. It has 3. It is much easier to lose 3 electrons, so it's going to throw those 3 negative charged electrons away. And when it loses those 3 negative charges, aluminum will only have 10 electrons. It's still going to have 13 protons, so it's going to become aluminum with a +3 charge. And so it's going to attract 3 -1 ions to it, or so. The octet rule. First off, we know octet means 8, right? So 8. The 8 rule states that in chemical compounds, atoms tend to have their orbitals, that wasn't the best wording, tend to have their orbitals filled with 8 electrons. Most atoms on the periodic table want 8 electrons. There's a few exceptions. We don't test you on the exceptions. But like helium only needs 2. It's the only noble gas that only needs 2 electrons because it only has 2. Its 1s sublevel is totally filled and it's happy. Also, things like lithium and beryllium, they'll lose their electrons so they become like helium. But most atoms, in general, it's going to be they want 8 electrons out there. Because if they get 8 electrons, they are stable. They have achieved what this one calls a noble gas electron configuration. So anytime you see a noble gas electron configuration, just think it means stable. That's the fancy $12 word for it's stable. So let's see. How many electrons does barium? Barium lives, right over there. It's right over here in group 2. So it's got 2 valence electrons. So let me see, Ba, 1, 2 on the Lewis structures. How many electrons does barium have to give up in order to become stable? Barium is going to try its best to become xenon, and it needs to lose these 2 electrons. If it throws away those those electrons, it's going to become barium 2+, but it will have the same electron configuration as xenon, but it would be xenon with a plus charge, actually a 2+ charge. So it thinks it's xenon, but that 2+ charge makes it act a little different. What is the formula? Okay, so like the formula for water is H2O. That's what we mean for what a formula is, H2O. 2 hydrogens, and there's an invisible subscript 1 right there. Let me zoom in a little bit more. There we go. So let's see, what is the formula for an ion when potassium achieves noble gas configuration? Oh, okay. Well, potassium, okay, let's look at it. There it is, K. It's in group 1. It has 1 valence electron. And it's going to throw away that 1 electron to become potassium. Okay, it's lost a negative charge. That means it's going to become K+. So we might write it like this, or we might even put a square bracket around it to let you know this is its new Lewis structure. When potassium loses that 1 electron, it thinks it's argon, but it would be argon with a plus charge and a little bit heavier, so it acts a little different, but that's what its formula would be, K with a plus, or like that. How many electrons does nitrogen? Nitrogen is right there. It is in group 5-tene, so it has 5 valence electrons, not 15, 5. That's why I mispronounced 15 to say 5-tene. How many electrons does nitrogen gain in order to achieve noble gas configuration? That means to be stable. That means to have 8 electrons in its outer shell, which means to get rid of any unfilled. So nitrogen over here, because it's a nonmetal, it's easier for nonmetals to gain electrons. It's going to need to gain an electron there, 1 right there, and 1 right there. So how many electrons does nitrogen have to gain? It has to gain 3 electrons. That one, and that one, to become like a noble gas. When nitrogen gets 3 more electrons, it thinks it's neon, but it's going to have a -3 charge, nitride. How does an ionic bond occur? Well, if you take a look in your notes, we had a couple of, or even on your packet. So one of the ways, the front of your packet will show you that. What does it say? An ionic bond? Ionic bond is when a metal bonds to a nonmetal. Okay, so this an element over here bonds to elements over there. That's one way. And let's see. So I'm just going to draw this zigzag. Okay, when one of these bonds with one of those, and as we saw over here, it can also occur when they gain or lose electrons. Gain or lose electrons. Metals. Let's see, non-metals will gain electrons. Metals will lose electrons. When metals lose their electrons, like let's say sodium, it becomes a plus ion because it's lost a negative charge, so it becomes plus. The non-metals, they gain negative charges, so like chlorine becomes a -1. Right, moving right along. Number 7, how many valence electrons? That's the outer electrons, the outer shell. How many valence electrons are transferred from potassium ion? Potassium lives, it's group 1, so it's got 1 dot, to nitrogen. Okay, so now we've got nitrogen, 1, 2, 3, 4, 5, because nitrogen, as we said before, is in group 15. How many valence electrons are transferred from the potassium atom to nitrogen in the formation of potassium nitride? Well, that potassium will give up that electron to nitrogen. So every potassium gives up 1. Now, you're going to need a total, though, of 3 potassiums giving up their electron. They become a plus ion, and the nitrogen is going to become a -3. So, but the question says, how many valence electrons from potassium to nitrogen? Each potassium is transferring 1. How does calcium, Ca, obey the octet rule? Okay, that means 8. When it's trying to form compounds. Hint, does it gain or lose electrons? Well, calcium has 2 valence electrons, because it's in group 2. Now, underneath it, the next shell down, its next shell has 8 electrons in it. So if it can throw away these 2 electrons here, which it does, it throws them away, because that's what metals do, it's going to become a 2+ ion. And if you could see inside of calcium, it's got 2 electrons in its first shell, its second shell has 8, its third shell has 8, and now it thinks it's a noble gas. We're working with calcium now thinks it is argon, but it has that +2 charge. So let's see, how does it obey the octet rule? By throwing away those 2 electrons, now its third shell is totally full and it's stable. It thinks it's a noble gas. This is crisscross. So crisscross. Na plus and N -3. You start by writing those out over there. And let's see. Well, I'm going to rewrite Na and N. That plus becomes a subscript 1. That -3 becomes Na3N1. We do not have to reduce any further. Let's try the next one here. We have aluminum +3 ion teaming up with oxygen -2. Make sure we got that. Okay. And we're going to rewrite the formula aluminum oxide. That -2 becomes the subscript 2, and that 3 we crisscross over to there. Then we need 3 oxygens. Because now 3 times -2 is -6, and +3 times 2 is +6. All of these ionic charges cancel each other out, and the whole atom is neutral. Even though it's made up of positive and negative parts, it adds up to being neutral. And our last one, this one throws you a polyatomic ion I'm going to put brackets around it. The SO4 always stays together. So when we go to do that, again, this is crisscross. Na with a plus, SO4, put a bracket around it. Every SO4 is a minus 3. Okay, we're just going to do crisscross now. Na, SO4. That plus, that's actually a plus 1. That becomes down there. So we have 1 sulfate, and the minus 3 becomes 3 sodiums. We're done. Which type of elements form organic compounds? Excuse me, sorry, ionic. Oh, we answered that up here. Okay, it's metals and nonmetals. Which type of elements form ionic compounds? I'm not going to write it out. Metals and nonmetals. Number 13, ionic compounds are normally in which physical state at room temperature? The best example of an ionic compound is table salt, and at room temperature, table salt are those cute little solid cubes. There we go. Or maybe you got a big chunk of rock salt. Okay. They are solids. Whoop, that was a terrible solid. S-O-L-I-D. There we go. Molecular compounds. That's a fancy way to say covalent. Are found in which states? Well, water is a covalent compound. Sugar is a covalent compound. We did that in our labs. And the air you're breathing is a covalent compound. So we've got liquids, we've got solids, and we've got gases. Covalent compounds, it doesn't take as much energy to hold them together, so they're not locked together as tightly as the plus and the minus ions inside of an ionic compound. What force holds ionic bonds together? All right, you need to go to your packet, and you're going to turn not to the first, to the second, past that, to the third. No, oh, there we go, this page right here. And I asked you right there, I'm going to zoom in on to, that's where it tells you. They're called electrostatic charges. That's what it's called when you have a full positive and a full minus attracting electro. Okay, there's some electricity happening. Static, that means that they're not flowing, but electrostatic attraction, they're stuck together. They're not moving around like electrons do, but that's it. Electrostatic, that's the official name for the bond. Electrostatic is what holds ionic together. Number 16, am I still, let me adjust the screen. There we go. How do atoms achieve noble gas electron configurations? Okay, that means they're stable, which for most atoms mean 8 valence electrons in single covalent bonds. So how do atoms, okay, a single covalent bond. So I had you work out some problems. If you have like, fluorine, or let's do chlorine gas, because sometimes they use that to bubble into pools. Chlorine. So now this should be a good place for you to look at, let's see, it was called the back of your crisscross sheet. It was this one right here. And one of the things we asked you to do, okay, one was oxygen. And you can see on this one, oxygen, because it has a -2 charge, because it has 6 valence electrons, it'll gain 2 electrons. But it ends up having a double bond. I'll even connect those like that. Now chlorine, because every chlorine only needs to share 1 electron. So this is called a single covalent bond. There's just one pair of electrons being shared. Chemists would tend to draw these like that. Oxygen has 2 bonds there. So chemists tend to show like that. And each of those means that there's 2 pairs of electrons. So 2 pairs. That would be a double bond. So they call this a double bond. That would be a single bond up there. So that was from your homework paper. How do atoms achieve noble gas electron configurations in single covalent bonds? Well, they share 1 pair of electrons. one pair, which we tend to draw like this, or maybe like this, or maybe just a dash, one pair of electrons. Why do atoms share electrons in covalent bonds? Well, coming back to this one, they want to be stable. This chlorine right here, when you cover up this one, this chlorine has 8 electrons. Cover up this chlorine, it has 8 electrons. They share electrons to become stable. To become stable, which means they have 8 electrons in their outer shell, which means they have achieved noble gas electron configuration. Oh, I went off the page there. Sorry about that. Zoom out. Sorry. Take a look there. Okay. Draw the Lewis dot structures. Oh no, come on. For oxygen, well, okay, oxygen, you should have it right there. I'm not going to redraw it. Okay, it had 6 electrons on each. Those 2 are sharing. Did that one. Chlorine, okay, we just did chlorine here. This is on your bonding basics. Okay, there's 1 pair of electrons to be shared. That's it. Did chlorine. Ooh, I don't think we did nitrogen. Nitrogen's kind of interesting. So nitrogen has 1, 2, 3, 4, 5 valence electrons. It's in group 5. And I'm going to draw the other nitrogen over here. 1, 2, 3, 4, 5. I'm putting the paired electron away. And now you should be able to see that these 2 are going to team up, those 2 are going to team up, and those 2 will team up. So we end up with, a chemist might draw it like this. 3 pairs of electrons being shared, and then there's its pair of electrons that it's got already spinning around. Draw the Lewis structures for oxygen -2 ion. You start with oxygen. 1, 2, 3, 4, 5, 6, because oxygen has 6 valence electrons. It wants 8, so it will gather another electron and another. There is the Lewis structure. Sometimes we'll go like this. If we actually do a dot, then we'll put the -2 up there. Nitride. Okay, nitrogen. 1, 2, 3, 4, 5. We drew that one before. It's going to gain 3 electrons. 1 there, and 1 there. So now we could put a bracket around this like that, or usually if you're doing dots, we'll make those dots and put -3 because every one of those we added was a -3 charge. Okay, now we got a metal. Sorry about the bouncing around. Calcium is a metal, so its Lewis structure looks like that when you start with, but then it's going to throw those away because it doesn't want those electrons. So its Lewis structure would end up being like this. Calcium, we're going to put a square bracket around it and put +2. It's lost those 2 electrons, so its outer shell that it used to have is now completely empty, and that makes it stable. Carbon dioxide, I think didn't we do one of those? Well, we were supposed to do it here, so I'm going to do it. This is on your bonding basics page. Carbon, 1, 2, 3, 4. Oxygen, 1, 2, 3, 4, 5, 6. I'm purposely putting the paired electrons away so they're not getting in our way. 1, 2, 3, 4, 5, 6. Actually, before I do that one, if we connect those 2 electrons together and those 2, we see carbon still has 2 electrons. So if it can find another oxygen, it can give, oh, I did it wrong again. Okay, well, we'll say, okay, oh man, I hate it when I put those in the wrong spot. I'm going to say this one's going to team up with that one, and this one will team up with that one. So I'll clean it up. You get that with the 2 dots over there. We'll clean up this one, 2 pairs of electrons being shared. So that's what you get there. So, all right, which of the following represents ionic compounds? Ionic compounds are metals bonded to nonmetals. So if you get a question like this, first off, you got to maybe, okay, remember metal to nonmetal is ionic. And you go through P and Cl. P and Cl both live over here. They're 2 nonmetals. That's going to be That's not going to be ionic. That's going to be covalent, actually. Nitrogen and oxygen, again, those are nonmetals. So that's not going to be ionic. That's what we're looking for. Barium and oxygen, a nonmetal, barium. Okay, we got a metal to a nonmetal. That's ionic. CS4, well, carbon and sulfur are both nonmetals, so that's not good. Those are going to be covalent. Okay, and then down here, we just added an extra word, number 20. Let's see, which of the following, let me zoom out so you can see the numbers there. Which of the following represents a biological molecular compound? Okay, covalent's the key term. Covalent bonds. Nonmetals bonded to nonmetals. Barium and oxygen. Well, okay, that's ionic. A metal and a nonmetal. Okay, that's ionic. We're not looking for those. Carbon, hydrogen, and oxygen. Carbon, oxygen, and hydrogen. Those are nonmetals. That's covalent. Carbon and hydrogen. Okay, if you got just carbon and hydrogens, yep, those are both nonmetals. That's going to be covalent as well. Hey, almost done with this part 1. Lastly, molecular compounds, covalent, are made from bonding. Well, we said it. No, nonmetals, excuse me, nonmetal with another nonmetal. And that is on the cover of your packet. I always try to make your packet covers have important information. Whoa! Did you notice there were all these electron configurations on there? That's cool. Oh, and there's a... Okay, never mind. Focus, last question. What is the net? Net means total, if you didn't know. The total charge of NaCl as an ionic compound. Well, by now, you should know that sodium with its +1 electron is going to give chlorine that. So what happens is sodium becomes a plus ion, chlorine is a minus ion, but all together, +1 - 1 equals 0. They're neutral. So we're done.